What you're looking at here is the ultimate camera cutting setup for Blender 4.5 onwards. As you can see, I have this animated camera with animated focal length and animated shift and sensor size, and the camera cutting setup is updating to all this in real time. And the best part about this is it's the simplest setup imaginable. You just add a single modifier after your scatter, and it will automatically cull based on your active camera and all of its settings. No drivers needed, no complexity. Just very simple and very reliable. You can also obviously change the active camera and have it automatically update too. So yeah, this is made possible in 4.5 because of a new node that we have access to called Camera Info, which basically gives us access to information such as the focal length of the camera, the sensor size, all this kind of stuff. But most interestingly, a projection matrix, which is a little bit complicated, but essentially it allows us to set up some planes, basically some view planes from the camera's point of view, to construct like a full camera frustum, which takes into account all of this information. And when used in combination with the active camera node, this is an extremely powerful setup. And the nice thing about this setup also is the fact that we're using basically only mathematical operations. We're not doing any like actual raycasting or geometry setups. So this whole process takes, like in this case, 0.37 milliseconds compared to my previous camera culling setup, which would take significantly longer. Which obviously in this case it doesn't make that big of a difference because even the old one was very fast too. But on larger scenes this will make a big difference. So there's a lot of sort of abstract math happening in this setup, and I want to just visualize for a second what's actually happening. So I've created some points in a volume here just to visualize some of the values we're working with. And essentially I'm going to delete points based on these values here. So first off, we construct a plane for the left side of the camera from the projection matrix, and I'll go over how that's done specifically in a second. But if I delete points based on this, you can see it deletes all the points directly to the left of the camera here, so it lines up perfectly with this axis line. And if we go into camera view, you can see it deletes everything just outside of camera. And we basically repeat this process 3 more times, so one for the right side, and one for the bottom, and one for the top as well. And this all works and updates as we move the camera around here. We then just go ahead and combine all these planes together basically to create the full frustum effect. And now if we view this in 3D, you can see we're seeing exactly what the camera's seeing. So how is all this math set up? Well, basically, if you want to recreate this, all you'll need to do is take row 1 and row 4 of column 1 of the matrix, add them together, and then repeat that process for column 2 and 3. And what that will give us is 3 values that we can then use to construct a plane out of. But we do this a little bit differently for all the different planes here from the projection matrix. So for our right side plane, we take row 1 away from row 4 in all 3 columns. And then for our bottom plane, we add row 2 and row 4. And then for our top plane, or one of them over here, we take row 2 away from row 4 for all 3 columns again on all of these. We don't really need to care about column 4 at all. But what do we actually do with these values once we have them? Well, we can use them to construct planes. So essentially inside this node group, which I'm using for all of these, we input these 3 values and output an SDF. So that's just a signed distance value based on wherever a point is in relation to that plane. So if I view this SDF, you can see that the values over here, they start at 0 at the plane and they'll increase to infinity as you go away from it and decrease as you go in the opposite direction. So the way this node group works is essentially it takes in the 3 values as A, B, and C, combines them into a vector and normalizes it. And this is essentially the normal vector of our plane. And we then dot product the position with this. However, we have to use this transform point node because if we don't use it, then this all happens at the origin. So the frustum is correct, but it's not positioned in the right place or rotated. So we just need to transform it by the camera's matrix here, which we can do using this transform point operation. And then we move all our planes to the correct place. We do have to invert it as well for some reason. And then the output of this dot product gives us our SDF. And yeah, we basically just do that 4 times for all our planes, combine them all with maximum operations, and then just delete our instances based on this output. You could of course delete points or anything else you wanted to as well, but I've just separated out my geometry into instances and ignored all the rest of it. So I can apply this as sort of a post-processing effect on any sort of object, just as a modifier that will automatically delete out all these instances based on whatever the camera is doing. So yeah, that's pretty much it for this. There is one more step you have to do at the very beginning here. I take the projection matrix, and if you don't do this step, I will show you the result. Let's just view our points getting deleted again. So if I put the camera somewhere in the middle over here, and if I don't do this multiply, you can see it's actually culling in the wrong direction. So this is just to sort of flip that around, and we just multiply it by this matrix here, which just replaces the 1 with -1 in columns 1 through 3, and then leaves 4 at 1. So that's just a way to flip the matrix around there. But yeah, overall, that's it for this setup, and because we're being so rigorous here using the projection matrix, we don't have to worry about any weirdness that often comes with, raycast solutions and that kind of thing. So this will be a much more robust and reliable setup for future projects done in 4.5. So hopefully you learned something cool about this. And if you want to go ahead and download the final file from the description with this culling node already set up that you can just drag onto any of your modifier stacks, then I'll put a link to that in the description as well. But other than that, thanks very much for watching, and I'll see you next time.